Okay, hello guys. Today we are going to be dealing with a data manipulation instruction that is greater than, less than, equal to, less than or equal to, greater than or equal to. So all those kind of instructions. These are critical instructions that we use in programming, especially if you master the basic principle of how they function. So we use these kind of instruction when you are doing like a protection, especially let's say you are controlling a pressure vessel. When your pressure exceeds above let's say 10 bar, you must switch off the compressor or you must open a relief valve. So you use this kind of instruction, as well as let's say you are controlling temperature in an incubator. When the temperature goes above 35.5 degrees, you switch off the elements. When it's below 34 or 33, you switch on the elements, all those kind of things. So I'm going to start with the greater than now. So I'm going to come here, instruction greater than, insert. So what it really means is like this instruction is a greater than comparison, and it only works on integer values. I'm talking about values like 1 2 3 4 5 6 8, and then it does not apply to floating points like 0,1 or 0,2. So let's say you're working with values that have got commas, those are floating points or real numbers. You must not use this kind of instruction. So what simply happens is like when S1 is greater than S2. So what it simply means is the data in S1, when it's greater than S2, the output is true. By true, I mean it's on. Okay, I mean it's on. So what's going to happen here? I'm going to say I'm going to put a normal open here. I'm just gonna name it M0, and then here I'm going to add a heater. My address is Y0 boolean. It's a heater, right? So that's what we have here. We have our heater, right? For example. So now your set point is the value that is in here. So our set point is 20 degrees, and then it's 20, it's just a number, it's just a number. I'm just using temperature. Is something that is very common. Even your air conditioner in the house, it does the same thing. So now I'm going to put information here. So at first I'm going to put 40 is greater than 20. So when S1 is greater than S2, you get an on here. I mean, when a number in S1 is greater than S2, you get an on here. But if it's vice versa, like let's say we put 10 here, the heater will not switch on. But it will only switch on when this condition is true. When it's like 21 here, this heater will go on. So I'm just going to start here by putting a number like 30. And then let me check my my communication manager so that we can simulate, because I'm simulating here. Because we are simulating. Okay, driver 2. I start driver 2. This is a newer version of communication manager. So make sure I've connected driver 2 exactly. So I'm gonna download my program. So these instructions, they work a lot. Right, come online. Right, don't forget, see my PLC is still in stop. I put it in run. Right, so in this case I'm going to, as long as you see this instruction, it needs like power. Just assume like the instruction needs power for it to execute this comparison. So if this M0 is open, no matter the condition that we have here, this instruction is not going to execute. So this point which is coming here is an enable instruction. So if this power, this contact at the back here is on, that's when only this instruction will execute. By execute, I mean it will do the comparison. So as long as we have got a false at the back here, or it's open at the back here, it's not going to activate. So when I switch on here, you can see my output is true now, because the instruction has got now power to execute. The instruction has been enabled. That's when you see 30 is greater than 20. Okay, so suppose maybe you don't want a condition for it to do the conversion, you just delete here, so that it just goes straight. If I just download this program like this instruction is just gonna execute there and there as you switch on your PLC. If you want a continuous comparison, but if you want conditional comparison, you put a conduct at the back here, so that the instruction only execute when that condition is on. So now I'm going to change this instruction to, let's say, 11. 11 is less than 20, so this thing must be faulty. So I'm going to download quick one. Right, as you can see, my instruction is false. It's false, but this instruction has been enabled now. The moment you switch on, the power goes straight, the instruction is powered, it did the comparison, and then the result is faulty. I'm going to change this as well to 40, like this. Right, it's on now. So what I did an online edit. I don't want to do this normally when I'm teaching. I want someone to do it manually. Finish, you download. But to save time, I did an online edit. You just click here and then you can edit while the PLC is online. You don't need to stop and program and change value and download again. So now you can see there's some changes now. So this value is now greater than that one. If I put 21, if I put 21, our value is still the same thing. If this value, if I make it bigger, 45, the number is 45, it means whatever is here is less than, it's not greater than what's here. It's supposed to be false, but why? I've even updated the new changes now. I didn't update the new changes. After this, see, it's off. So that's how you use a greater than comparison. So now I'm going to take it a bit further. What I'm going to do now, I want to do a small program here. You want to see, but okay. 14. Right, I want M1018 here. Then I want to see NGC01000. Right, so this is a counter. This counter is going to keep counting, so we just assume our counter is a temperature probe or a temperature reading or wherever we are getting data that you want to compare, or it's counting bottles. This counter is counting bottles. This is a sensor that is counting bottles. I'm going to do a lesson about the counter, so just ignore this part. So we have 19 bottles. We are picking, let's say, 10 bottles at a time. When 10 bottles passes by, we must get a light must switch on, or a heater must switch on, or whatever. So this data is coming from C0. Now this data is coming from C0. So the moment the PLC switches on, this value is going to start counting. When it's greater than 10, this will go on. So this is now automatic. Now I'm no longer putting values. Okay, I'm gonna switch it on now. You can see 3, 4, 5. When that number is greater than 10, it will switch on. When it's equal to 10, it does not switch on. You see, it only switches on when it gets to 11. So that's how this instruction works. So I'm going to do the same instruction. I'm going to change it to less than. So what I'm going to do now, I'm going to leave the rest. Then I'm going to change this instruction to a less than instruction. So if you notice, when it goes to 9, 10, it didn't switch on. It only switches on when it's greater than. That's when it's 11. Okay, so now I've got a less than. Now I've been putting values manually way before. So now we're just going to use our same counter, C0. And then our set point remains the same. We'll put 10. So how this one works now, if the value that is here is less than the value that is here, so it's simple. You just take, when you are reading this instruction, you say S1 is less than S2. So you put your comparison in between these two values. If the value that is in S1 is less than the value that is in S2, it's a true. You must get true. So which means I must change this condition. If the value that is in S1 is less than, so at that moment we were switching off and on our heater, something like that. So if the value that is oh, I made a mistake because the heater was going on or what, but right, it's fine. Let's just continue. This is just a tag. In fact, because if I say heater now, when I was way above, I was switching on the heater instead of switching it off. But it doesn't matter. It's just a tag. It's just a tag that you can change here from heater to because if someone now is saying he's now above 10, he's switching on the heater or whatever, it doesn't matter. It can be light to make it easy on the guys. Because the mistake was on the interpretation, like someone is saying, but it's greater than 10 or whatever on the earlier instruction. Okay, so we are here now. We are saying when C0 is less than 10, the light must go on, right? So I'm gonna download now. Okay, the light is on now because this value is less than 10. 8, 9, 10. You see, 10 is not less than 10, it's equal to, so it doesn't meet this condition. So that's why our light is off now. That's why our light is off now. So I'm going to run it again so that you can take a look. 1, it's on, 2, 3, 4, etc., etc. So that's how it works. So now, if it's a temperature controller, and I'm going back to the heater now. The heater, this is supposed to be the heater now. When your temperature is less than 10, the heater must be on. When you're now above, the heater should be off. Something like that. So that's how these instructions, they work on the comparison. That's how they work on the comparison. So I'm done with the less than. I'm gonna move on to the equal. Okay, cut. Let me get the equal. The equal, I'll put a 10. I'll put a C0. So this one now is different from those other two. This one only makes the switch on when its condition is true. So when the data that is in S1 is equal to data that is in S2, that's when this thing goes on. So I'm just gonna download now. 1. It's taking longer. Okay. This is supposed to switch on only on 10. Only on 10. 9, 10 is on. On 11 it's supposed to be off. So it only switches on when the condition is true, when S1 is equal to S2. So that's how it works. This one, if you have questions, just comment in the comment section. Usually 1 subscriber out of 5 viewers. That's what I normally get. So just make sure you are the one who's going to subscribe after seeing this video. If you are benefiting, just click on the subscribe. If this information is helpful to you, if it's adding more to your knowledge, just appreciate it by just subscribing. Thank you very much. So now I'm gonna move to greater than or equal to. Greater than or equal to. I'm not going to do the float. I'm going to do the floating on a different video. So I've selected the less than or equal to. The less than or equal to. So this is now less than or equal to. So what happens now? This is similar to the one that we had earlier, but that one only switches on the equal on 10. On 10. So this one will switch on from 0 to 10. You see. So what I'm going to do, let me do it by showing less than or C0. We're gonna see now. Just gonna download. Was equal to does not switch on 9. Does not switch on 1 to 9. It only switches on 10. But this one now is the one that I normally use. I don't usually use less than. Normally I use less than or equal to. It's the instruction that I normally use when I'm doing comparison. I don't like less than only. So 8, 9, on 10 it switches off when it's now above. When it's now above. So what it simply means is like 9 is less than 10. And then 10 is equal to 10. So we have got less than or equal to. So that's why it's managed to switch on 10. So if you saw the other comparison on equal to, you must get the difference now. You must get the difference now. So if you didn't catch it, just go back to the video and watch the simulation on equal to. You will see the difference. The difference is that the equal to does not switch on. It only switches on once when the value that is in that register is the same as the other one. Okay, so I'm going to greater than now. Greater than or equal to C0. Someone is wondering what is happening to that counter which is at the bottom there. I'm just going to show you. This is a 1 second clock pulse. I think I did a video on these pulse registers. So what it does, it just flicks. It just flicks after every 0.5. So it goes on, off, on, off. And then this counter is counting those pulses. So I'm using that to count here. So you might be wondering, yo, what's going on? Why is that counter counting from Norway? So that's the trick. So just use these instructions wisely. They are very helpful. They are very helpful, especially with analog signals. You have to use this. So 4, 5, only on 10, 10, 11, and all the way up until the register is full. So this is what's happening here. Off, on, off, on. It's counting the pulses, and then I'm using it for comparison. So this is what we have on the comparison. instruction. So I think I'm gonna have to do which one do we have here? One that is left. Okay. All right. So this one I'm not gonna do it. Maybe I can. Okay, let's do this. This video is gonna be a bit long. I wanted it to be 30 minutes. All right. Okay, so what I'm going to do, this is S1 not equal to S2. We must get a true. I see we're saying greater than now. Okay. All right. So this one is only going to switch off. Is the opposite of equal to. Is the opposite of equal to. This is the opposite of equal to. So see, all along it's gonna switch on. It's going to switch off only when it sees 10. So what I'm going to do, I normally create questions and then I put an answer. I'm going to be creating questions using this instruction so that you can really understand when to apply them. Okay, 3, 4. It only switches off on 10. It only switches off on 10. There. The rest is on. So it's when S1 is not equal to S2. It's not equal. If it's 1, it's not equal. If it's only 10, that's when it's only equal. So what I'm going to do now, in the next lesson, I'm going to put a question, and then I will use this instruction in a question, and then you really start appreciating, especially application on when and how to use them. I'm just gonna restart this one again, so that you can see again how it works. Only when it gets to 10, that's when it switches off. So where you can use this, where can you use this? Was I'm going to really draft questions so it switches off on 10, switch off on 10. So you can see you can use this in temperature control, pressure, where there's analog mostly, where there are integers involved. So these functions, as I'm going to repeat again, they only apply to integers only. I'm going to do another video, but this video is going to be very long if I put floating points here. So there are similar instructions, but those ones are used for floats. There are similar instructions, some of them that are used for double word register. This is not for double. This is for just a 16-bit data. These registers, these instructions are only for 16-bit data, not 32. You don't apply this when you're comparing data that is above like 32,700 or something, 32,776 something, around that kind of a number. You cannot compare. You need a double. So I'm going to do an instruction for double, instructions for comparison, instructions for floating points as well. So both they are different kind of instructions. Otherwise, if I'm to put a bigger number here, it will tell me I can't compare. So let me just do let me try like say 400,000. You see, it does not match. It's because of the size. It's because of the size. Even 40,000, I'm sure. I'm not sure. Let me try and see. You see, it's around 32,740 something. I'm not so sure. But if you put 30,000, I'm sure it will accept. You see, so it's only for 16-bit data. 16-bit data. I think you really understand better now. It's only for 16-bit data. If I put a float, if I put a 0, 0.2, 0.5, then I come. So please just click the subscribe button. Just click the subscribe button. Thank you guys for watching. 2.5, you cannot compare. It's only for integers. It's only for integers. So thank you guys. I can't even simulate here because there's an error here. So thank you guys.